Okay, good morning everyone. We're super excited to be here. As I said, I'm Camille Fournier. I'm the CTO at Rent the Runway. And I'm here to talk about microservices, specifically the people's history of microservices and monitoring for the small fry. Oh, on-call. It's not a happy time right now. I saw this come through my Twitter feed recently, and I knew I had to save it because I would use it in some talk. And I noticed on the tables outside that we even have people selling monitoring solutions talking about how bad on-call is. So, on-call right now is pretty bad for a lot of people. And hopefully, at this conference, we'll get a lot of ideas on how to get out of the situation that we're all in right now. Kind of cool tools, techniques, things that we should be learning and practicing in order to help improve our monitoring stacks and make the on-call process better for our teams. But I thought that it would be interesting to start this talk off by asking the question first, how did we get here? And specifically, how did we get here for those of us who are working in this sort of microservices, very heavily distributed systems environments? So I thought it would be fun to write a talk about a people's history of microservices. So my muddled memories of living through the last 20 years or so of the computing evolution. This is a really up people's history, my own personal history, but certainly not the history of the people who created massively successful, gigantic, distributed companies like Netflix, right? Which have also great talks that you can go see and talk about last year, right? So this is my history. Because in the beginning, when you were doing application development, it probably looked something like this, right? You had these very simple three-tier architectures. You had some kind of presentation layer, you had your application layer, you had your data access layer, probably a database of some sort. And most of us who did application development worked in this model, right? Now, yes, technically there might be a network here, but I don't think that any of us who were writing code at the time would have claimed to be really writing a distributed system. In fact, I love this Leslie Lampert quote, a distributed system is one in which the failure of a computer you didn't know existed can render your own computer unusable, okay? If you are the application developer in that three-tier architecture, you probably know where the database is, right? If the database fails, it's not that you didn't know it existed, right? You know it exists. You probably even know exactly what its name is, what its IP address is. So the problems that we were dealing with when building these three-tier architectures were mostly just about writing the code that we needed to build to serve our application's needs. And lucky for us, we had some Moore's Law at our backs, and when we wanted to scale, we could just buy a bigger computer, right? Transistor density was shrinking, processors were getting faster all the time, memory was getting more dense all the time. It was awesome. Unfortunately, even by the time that I was in graduate school in the early 2000s, we were talking about how Moore's Law was coming to an end. We couldn't keep making these processors faster and faster and faster by, just shrinking our transistors. We instead were making more compute available on a single machine by adding more cores or the ability to process more threads or more processors, but we were not actually enabling single-threaded, single processes to scale and become faster and do more on a single machine. So we're starting to hit our limits of vertical scaling. We're also hitting this time when everybody's going online and a ton more data is being produced. And disks really aren't getting that much faster. I mean, Flash happened at some point, and that was pretty awesome, actually. But, spinning disks, still kind of slow, really hard to optimize for. And so this vertical scaling that we were all used to was starting to come to an end. And along comes Google, okay? And for those of us who are my age, who were in the computing industry at the time, Google blew our minds a little bit, right? It was, the things that they were doing were awesome. Talking about these gigantic clusters of commodity hardware, where they were building these gigantic distributed systems in order to process all the data that they needed to do the Google thing, right? If you had heard of Beowulf clusters, you may have heard of this concept, but most of us weren't running anything anywhere near that, and Google was talking about how to actually make this real. The Google MapReduce paper comes out in 2004, and Hadoop is on its heels in 2005, open sourcing some of those concepts, right? You get Bigtable in 2006. The Amazon Dynamo paper comes out in 2007, and we start to see this massive explosion of distributed data storage systems, right? Distributed data storage and access is what I would really call most of these frameworks with a little bit of data processing, right? But they weren't application systems so much, right? It wasn't about building business application logic. It was really about these gigantic distributed, more systems-y systems, which meant that they were still being written by systems engineers. But we're all getting super excited about this. I'm sure all of you are probably still pretty interested in this evolution because it's really cool and really hard, and distributed systems are kind of fun to think about. Okay, path number 2, we're switching paths a little bit. Amazon Web Services comes out in 2006 and blows our freaking minds, right? Up until 2006, I can tell you, as a person who used to work in a big enterprise, if you wanted new compute power, you waited for your ops team to rack hardware for you, and it took 3 to 6 months lead time. And it was very, very slow. And getting hardware set up, getting that compute power that you may have wanted, just took a really, really long time. Amazon comes in with this ability for anyone who's like vaguely qualified to requisition themselves compute power and kind of blows our minds, right? And Heroku comes on its heels in 2007 and not only shows us like the ability to easily requisition hardware, but this almost like magical pipeline of just being able to deploy and scale very, very quickly. And everyone starts to think that they need to build their own Heroku, which is kind of where I think we still are right now. But the big revolution in my mind that comes out of this is that all of a sudden, developers had the keys to the kingdom of heaven, what had once been operations specialist territory. Now, developers are not going to sit around and wait for 3 to 6 months for ops specialists to go in and configure the Amazon Web Services instance, right? They're like, hey, I don't need to wait for you. I can do that myself. And the ops folks are like, well, okay, you can do that yourself, but I am not going to support that shit. Are you kidding me? Like, absolutely not. And so we end up in DevOps. Is awesome. I love the DevOps. I think the ultimate outcomes of this movement are great. Encouraging those two groups to really work closely together and stopping the habit of throwing things over the wall and stopping the habit of being the slow down bottleneck. But I do think that this would have been a very hard sell were it not for the fact that developers could at least try to do these things themselves. So you've now got developers, especially at small companies where you don't really have enough time or money or whatever, wisdom to hire operations specialists. You've got developers pretending to play ops on the very unstable hardware that is the cloud. Okay, so thread number 2. Thread number 3. The monolith and the sort of Ruby on Rails evolution. I notice I stole a lot of slides in this talk because, I think you can see the history of computing as told by many other people's talks in the past. This was actually great, right? These monoliths, these monorails, these other things, right? It's not just Ruby on Rails that people use for this. There are Python frameworks and PHP frameworks, but people build these big monolithic systems. And they built them fast, and they were able to get a lot done on these systems. Look, Twitter was built on Ruby on Rails as a monorail. And yeah, it caused them a lot of problems, but they built a successful business. They built something that people wanted to use, and they were able to build it really quickly. And that's nothing to snub your nose at, right? That's actually like pretty cool. Unfortunately, that doesn't usually scale for most of us very, very well. You can scale monoliths. Of course, Etsy loves to tell us about how they do it all the time. And Etsy, I love you. I think you guys are amazing. But I was in a monolith, and my monolith was not nearly as well written as maybe whatever Etsy started with, and I don't know PHP, so my team at Run the Runway did this natural thing that everyone else did, maybe not everyone else, but almost everyone else did, when faced with one of these monoliths, which is that we started moving it out into services, right? Because it's actually a very smart way to get yourself out of a big, tangled, complicated, monolithic architecture is to pull out pieces of functionality one after another, and it's easy to spin up hardware, so you might as well move it into separate services where you can really enforce the separation of concerns that actually makes code easier to think about in the long run. Of course, then you end up with terms like this, which Adrian showed us last Monitorama. Okay, the Death Star architecture diagrams. I don't know about you guys, but Death Star is a terrifying term to me for architecture diagrams. I like it, I think it's cool, but it's like, this is scary, right? This is a little bit like, oh my God, what's going on here, right? So instead of one really complicated single sort of piece of software, you've got, with a very relatively simple overall system complexity, you've got a whole bunch of hopefully simple pieces, independent pieces, but your overall system complexity is incredibly high. And in essence, what you have here is a distributed system written by application developers. So you start to see a lot of talks these days about the principles of microservices, all the things that you need to be doing in order to make a successful microservices architecture. And I don't disagree with these. I think these are great principles. But, you know, I think that they're a little bit misleading because most people aren't really thinking about all these principles. They're just trying to think about how do I get my system out of this, like, unscalable monolith. So to quickly sum up, we had these three-tier architectures that we couldn't scale. Google comes along, blows our minds, distributed systems, right? Then we had Amazon Web Services come along, which gets the key to the kingdom of heaven are given now to the developers, and once had been held by ops, and now we have DevOps. And we have these monoliths that we also weren't able to scale for either development reasons or actual physical scaling reasons. So we moved into this microservices architecture in order to continue to keep our development speed up, which means you've got application developers running distributed systems on unstable hardware that they're kind of supporting themselves. And all of this is happening, for most of us, under conditions of scarcity. And this is the point that I feel like is often missed when you hear these conversations about the microservices evolution and even DevOps to some extent, right? We spend a lot of our time talking about these things in terms of shoulds and musts and best practices and all the things you have to do. But look, scarcity, this is probably more talking about economic scarcity. I'm going to go ahead and guess. I just Googled image search scarcity. I like this. When you are juggling a million different things, the thing that may be burning down for you right now is your monitoring framework. But tomorrow's thing that's burning down for you is the fact that you are not getting that feature done that the CEO really, really wants to see happen. And you're not always making the best and most thoughtful and most long-term decisions in this environment. So Martin Fowler's been talking about microservices a lot, and he's written some pretty good blog posts, and he has this graph, which I like. You know, it shows how, like, early in the game, you probably do want to start with a monolith, right? Because when you're using that monolith, you have few developers, you're just trying to get code up, figure it out. The complexity of trying to operationalize a bunch of microservices makes you overall slower than if you were just working in a monolith. But at some point, you have this inflection point where microservices makes you significantly more productive than trying to continue to work in a monolith. And here's the thing. It does not require you to be in an operationally perfect environment to hit that inflection point. There is no guarantee that you are going to hit that inflection point when you have everything perfectly automated and your monitoring stack is perfect and you understand how to isolate failure throughout all of your systems. So this is the situation that so many of us that are in microservices architectures are in right now, right? We hit the inflection point. It made sense for us to move to our architectures, but we were not perfect when we made that switch, and we're still struggling to catch up. So let's take a pause, let's take a breath. What the hell do we do? We're in this imperfect situation. And how does monitoring fit into all of this? How do we start to learn from the talks that we're going to hear today about how we can dig ourselves out of this hole? Particularly for those of you who work at small companies like mine. Rent the Runway has about 65 in the engineering team, and that includes IT, actually, so fewer than that developers, right? How do we dig ourselves out, given that we don't have a ton of resources to put against monitoring and automation of all the things? So when I have questions like this that I'm trying to solve, problems like this that I'm trying to address, I try to boil them down to their essence. What is it that I really care about? So what is monitoring anyway? What do I, as a CTO, care about when I think about monitoring? I think about two things, okay? Number one, I want to identify the cause of known problems quickly. Okay, something is wrong. I know something is wrong. I want to figure out what's wrong and fix it as fast as humanly possible. And number two, I want to understand the state of the system at all times, but really, mostly, I care about that because I want to be able to detect hidden or upcoming problems. Yes, I mean, I care about it in general, but look, I mostly care about when things are burning down, right? They don't bother me when things are not burning down. That's why I'm a CTO. So, part one, identifying the cause of problems quickly and other incident management improvements. So here's the thing. Back in that 3-tier architecture that I talked about, so many 15 years ago, we actually still had to build software, and if it was broken all the time, our customers would be really unhappy. So we learned a few things, even back then, on how to identify problems quickly and how to build software that people would want to use. And one of the things that we learned back then that people seem to be weirdly aggressive towards right now is testing. Ooh, yeah, I know, super boring, right? Testing. Oh, but you gotta test, okay? I took this slide from Sandra, who gave a great talk on distributed systems testing at Craft, and you can find it online. I recommend you watch it if you're interested. Why do we test? We test to gain confidence that our system is doing the right thing now and later, okay? Testing is essential. You cannot get away from testing via awesome monitoring, right? You do not want your customers to experience outages. Cool, you can make it so that monitoring helps you have them experience short outages. But testing is about more than that. Testing is about knowing that your code is actually doing the right thing. Testing gives you a bit of confidence that if you're seeing problems, is it within one of those sort of simple systems around your microservices Death Star, or is it within the interaction between all the systems inside your microservices Death Star? Right? Testing helps you change your system. Monitoring is not a substitute for testing. Please stop saying that. It's just not, that's not a good thing to say. It doesn't make any sense. And I don't actually think that anyone that really has amazing monitoring environments thinks that you should actually not test, right? Monitoring lets us take a bit more risk, lets us reduce release code a little bit faster because the risk of change is reduced, but it's not a substitute. Okay. Speaking of other boring things that you probably want to consider doing, even though maybe they're not the cool hotness, articulating dependencies, right? I don't mean writing clear POM files. I mean understanding what healthy looks like for your system and understanding what healthy looks like in terms of downstream dependencies, right? If you don't understand the downstream dependencies of your distributed system, it's really hard to figure out when a failure is due to errors within that system or errors in the environment at large. Moreover, I actually think it's a good idea to write runbooks. I actually think it's a good idea to enable developers to hand off the support of systems that they write. I know this is a very, the popular opinion, or I don't know, the loud opinion maybe, these days seems to be that developers should support all their code. And I actually think the developers should support their code. But here's what happens when developers support their code, right? This happens to me. You get an alert, okay? The developer glances at it, and they say, oh yeah, that's no big deal. That's just like the network sort of shitting for a minute. Like, no biggie, ignore it. Oh yeah, that's just that downstream system, ping that guy. Oh, ooh, this is actually my application. Look, let's figure this out really quickly because this is a big deal. I don't care if it's not DevOps. If you have a small startup, so I mentioned we're at the runway of about 65 in my engineering, in my technology team. Let's say we have 50 coding engineers, and that probably includes a few people who are really mostly managing. I've got more than 40 services in prod. So I have almost a service for a developer. And developers quit. They quit all the time for reasons good and bad. Even if you are the most amazing manager ever, your team members are going to quit at some point. And if you had no documentation and no understanding of truly how to support your systems in prod, you're going to be in for a lot more pain than you might otherwise be if you force your developers to actually spend a little bit of time production hardening the systems so that other people can help them support those systems. So I know this is not, I think developers should support their code, but I also think that spending a little time getting systems in a state where they can be handed off to others is a useful exercise. And there's a reason that a lot of big, smart companies still do it. Okay, what about tools? Finally, this is a conference about monitoring. What about the monitoring tools? My only personal advice and experience here. You like this? I'm pretty sure Coda Halo gets a shout out for that, that lovely image. Okay. Similarly to, look, it's bad when you have a million different tools for your storage layers. It's bad when you have like a million different monitoring tools. There are Java developers that write their code in VI because they don't feel like learning an IDE, which is silly. That's why you hate Java, because you're not using an IDE, or maybe not, but right? If you want to learn the thing that will make your job so easy, so much easier when you're writing code, why would we ever expect our development team, who is supposed to be supporting the software that they're writing, to learn a million different monitoring tools? They're probably not. So pick a few, right? 2, 3, but probably not 10. And it's, that's tough because there are a lot of great monitoring tools out there, right? A lot of people, if you're a CTO, you're going to get emails every week about the newest hotness in monitoring, and somebody's trying to sell you something. You get used to ignoring those emails because, to be quite honest, you can't possibly learn and adopt these tools and train your team on them well enough to make it worth your while at a small size. In general, I think the best philosophy, unless your team, unless your whole company is all about building monitoring, is consistency and clarity over creativity. This is not the area for you to go and be crazy creative in, right? If you are running a business that has nothing to do with monitoring, you just want your monitoring to be usable by everyone who has to use it, understandable, and to help your incident management process go well. Okay, part 2, detecting and predicting things that are wrong without alerts, and operating well enough when things are failing. So this is the part of the talk where I am hoping to learn a lot from all of you today and tomorrow on this topic, because I think there's a lot of, there's a lot of like, ooh, statistically significant, and when do we do this alert, and like doing really smart alerting. So I find that to be kind of overwhelming, unfortunately. I know I shouldn't. I know there's like 10 Etsy talks that are about like how you shouldn't make that overwhelming, and it should just be totally like, oh, it's so biggie, just like make a graph and then it's cool, and make another graph and then it's cool. Okay, fine. I still haven't successfully managed to adopt that. But I will tell you that if you are just starting out from scratch, if you are early, if you are small, if you are scrappy, there's a few things that you've got to do, which is keep history and look at it, right? You've got to understand your trends. These are fashion trends, because I work for a fashion tech company. We rent a lot of prom dresses. If nobody's renting prom dresses, that is a very much out of trend event. And understanding the trends that are going on with your business is going to be important for you when you go to figure out whether something is wrong or not. History is important because it will help you understand when things have changed and help you narrow down the cause of changes in behavior, right? So keeping history, even if you're not doing anything with it, is valuable because you probably will need to do something with it in the future. The other point here is that the most useful data that you have is an approximation of your business, okay? What is your customer experiencing? What is the client experiencing? What are the rhythms of your business like? You probably are thinking, when you think about monitoring, you think a lot about like your core like data stores are the most important thing to monitor, but don't forget that at the end of the day, your customers are what is most important. If your customers are still surfing the site and checking out or doing whatever action it is that is most valuable to your business, it kind of doesn't matter that your team is thinking about what's going on in the present moment and predicting what's going to fail. The final point I want to talk about is resilience. Robust distributed systems are harder to write than robust single machine systems. We know this. This is true for your stack. This is true for open source. This is true for your vendors. This is true for everything. So what you hear a lot when we talk about resilience of these architectures is planning for failure and trying to degrade elegantly and making it so that you have no single points of failure. And the point that I would like to make is that you can, in fact, overplan for failure. And if you overplan for failure too early, it's going to cause you problems. So this tweet has been very popularly retweeted. One service dies, the whole system breaks, you don't have SOA. You have a monolith whose brain has been chopped up and stuck into jars. I'm sorry, but I must respectfully disagree. That is nonsense, okay? If any of your services can die, meaning any single one of the whole batch can die, and your system breaks, yes, then you have a monolith whose brain is stuck in jars. But that is not the same thing as having a single point of failure. I work for Rent the Runway. What does Rent the Runway do? We rent dresses. We rent designer dresses and accessories. The reservation system is down. Like, that's okay. In fact, the story that I have to tell you about this is that when we were starting to move to microservices, I actually had an advisor coming in. So we were already moving to services, and this advisor told us that we should do this thing called swim laning, where we made it so that every single page of the site, every single major page of the site was like independently deployable, and we created something that looks like this, which is really, I can't even explain it, right? We were trying to create this totally independently scalable, fault isolated, fault tolerance, geodiverse, blah, 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 blah. And what ended up happening is we created a system where it took our developers like 4 hours to deploy our storefront code, and developers would code in isolation on branches, and it was just a mess. It was over planning for fault tolerance too early in our business. We did not need this. We actually weren't having this problem at all. So rolling all of this back on our front end and basically having for our front end code what is essentially a monolith has made our lives better and actually made us probably more reliable because it's so much easier for us to deploy code. So you can actually plan for failure too early and too much, and it will cause you more problems in itself. Okay, so in conclusion, we are all in this together. Every single person in this room works for a company that has warts and spit and duct tape. I know you all do. Big companies, small companies, nobody is perfect. There is an underside to every wage about which history does not often speak, because history is written from records left by the privileged. That is sort of the inspiration for the title of this talk, A People's History of Microservices. Because so often at tech conferences, we hear from the privileged and people who are trying to sell you something and people who have, really a lot of rosy things to say. But honestly, most of us are actually experiencing a reality that is somewhere in between, everything's on fire all the time and everything is perfect. So, take a breath. It's okay. You don't have to have a perfect culture. You don't have to be a perfectly enlightened human being or a group of human beings, right? You don't have to have perfection throughout your architecture. Enjoy the ride, have fun, and test your freaking code. Thank you. Not take questions, but I will happily talk to anybody individually after this. So please feel free to reach out to me individually, but I'm going to let the next person go on. Thanks.
Thanks, Camille. So I'm